So this is the outline of today's class. So we are going to discuss about the construction and working principle of DC motor, followed by the torque equation, and then the types of DC motor, and finally we are going to discuss about the characteristics of DC motor. DC motor, the machine which converts electrical energy into mechanical energy is called a motor, and if it converts a DC electrical energy into mechanical energy, then it is called as DC motor. That means this motor operates under DC power supply. Main parts and construction of DC motor. Here you can see yoke, field coil, and field core, then armature core and armature conductors, commutator and brushes. These are the parts of the DC motor. Here you can identify that the outermost covering is called as yoke or frame, and then here you can see the field core, and it is wounded by the winding, field winding, and then field shoe, right, or pole shoes. Right. Next one is the armature conductor, which is cylindrical, armature core, which is cylindrical, and you can notice the slots, and in that slots, the armature winding is wound on it. And then you can see the commutator. Okay, like commutator is mounted on the shaft, and then here the brushes are noticed, but it is placed on the commutator, right? Principle of operation. When a current carrying conductor is placed in the magnetic field, it experiences a twisting force, and that force we call it as a torque, right? And in order to produce the torque, we need two things. One is field winding for producing magnetic field, and another one is a conductor for carrying the current. Okay, and this is the basic principle of operation of a DC motor, right? And the current is a DC current. Right. Here you can see the diagram demonstrating the principle of operation. In the first diagram, you can see there is a magnetic lines of force from North Pole to South Pole, producing the magnetic flux around the conductor. In the second diagram, you can see the conductor carries current. So that plus mark or cross mark shows that the conductor carries the current. And because of the conductor carrying the current, there is a flux around the conductor. We know that the current carrying conductor produces a flux, right? So this is the flux due to the current carrying conductor. And here you can see the flux due to the magnetic lines of force, right? So now there are two flux. Okay, and in the third diagram you can notice the interaction of two flux. So there is a magnetic lines of force due to the magnet, and there is another flux due to the current carrying conductor. And if you see the left hand side, both the directions are same, like the direction due to the magnetic lines of force, the flux due to the magnetic lines of force, and the flux due to the conductor, both the flux directions are same. That means it aids, is an addition, right? And in the right hand side, you can see both the direction are an opposite direction, so there will be a cancellation effect. And because of that, you can see the direction of force. So here the potential will be higher, and here the potential is lower. So you can see that there will be a force, or like the direction of force, from a strong flux to a weak flux. Okay, and that is the principle of operation of a DC motor, right? Okay. Okay, the direction of rotation of a motor can be determined by Fleming's left hand rule, which gives the direction for lines of flux. Okay, the middle finger gives the direction of current, and the thumb finger gives the direction of motion. Okay, so that is the rotation, direction of rotation of motor. Right. In motor, you can notice that the armature starts rotating and cuts the magnetic flux. Okay. Hence, according to Faraday's law of electromagnetic induction, there is an induced EMF in rotating armature conductor. Okay, so there is another EMF in the armature conductor that opposes the supply. Right. Okay, that opposes the current supplied to the armature conductors, and that EMF is called as back EMF. Okay, and it gives the equation is EB is equal to 5P N Z by 60 into A. So this equation is an EMF equation for a DC generator. Okay, and that is called as back EMF in DC motor. Right, back EMF significance. So the main importance or advantage of having this back EMF is that it can produce a self-regulating action. Like for example, when a load on a motor is decreased, then the torque will be more, right? So the armature is accelerated. So when the speed is accelerated, when the speed is increased, the back EMF is also increased and causes the armature current to decrease, so that it can prevent accidents. Otherwise, if the armature current is very high, it may lead to fire or accident. Okay, right. Voltage equation of a DC motor. The terminal voltage V is equal to back EMF in the armature conductor plus the voltage drop across the armature, that is IaRa, and then plus the brush drop. So the brush drop is very small, that is negligible. So it can be modified as V is equal to back EMF plus the drop across the armature conductor. Right. Whereas if you want to find the armature conductor, then you can use this equation, the terminal voltage minus back EMF divided by resistance in the armature. Torque equation of a DC motor, right? So we know that the power in armature is equal to torque multiplied by the angular rotation. So we know that power in armature is given by back EMF into armature current. That is equal to armature torque is equal to armature torque can be written as TA, and the angular rotation is written as 2 pi n over 60. Okay, n indicates the speed in RPM. So if it is divided by 60, then in revolution per minute, second. Okay, right. But we know that EB in a motor is given by, EB means back EMF. It is given by 5P NZ divided by 60A. This is the EMF generated back EMF. Okay, substitute in the first equation, and then you will get the torque equation of the DC motor. Okay, so which is 0.159 multiplied by flux into armature current multiplied by PZ by A. Types of DC motor. Okay, there are different types of DC motor based on the way of connecting field winding with armature winding. Okay, like DC shunt motor. That means when field winding is connected in parallel to the armature, then it is called as DC shunt motor. And next one is DC series motor. That means when field winding is connected in series with the armature, then it is called as DC series motor. And the final one is the compound motor, where a part of the field winding is connected in series and another part is connected in parallel. It is further classified into long shunt and short shunt based on the type of connection. DC shunt motor. So here you can see that this is the field winding which is connected in parallel to the armature of the motor. Hence it is called as a DC shunt motor, and the voltage current relationship is given by, this is the terminal voltage. Terminal voltage is equal to back EMF in the armature plus voltage drop across the armature, that is IaRa, plus voltage drop across the brush. Okay, this will be negligible. Okay, so this is the voltage equation of the DC shunt motor, and this is called as constant flux motor, as the flux is directly proportional to the shunt current. Okay, and it is not going to change, therefore it is called as constant flux motor. DC series motor. So when the field winding, here you can see the field winding is connected in series to the armature, hence it is called as series motor. And the voltage equation for this DC motor is the back EMF in the motor plus voltage drop across the armature conductors plus voltage drop across the series field winding plus the plus the voltage drop across the brush. So altogether we will have the terminal voltage. Compound motor. So here you can see the part of the field winding is connected in series with the armature, and the part of the field winding is connected in parallel to the armature. Hence it is called as compound winding. Further, it is classified into long shunt and short shunt. Long shunt means the connection will be like this. Okay, the shunt, the field winding is connected across this series operation, like the series of armature and the part of the field winding. If the shunt winding is connected in parallel only to the armature, then it is called a short shunt. Okay, here it is called as long shunt. Long shunt means Both are connected in series, and this shunt winding will be connected in parallel. Whereas short shunt means only this armature will be in parallel to this shunt field winding. Characteristics of DC motor. Here we are going to discuss about three types of characteristics. One is the characteristics between torque and the armature current. Okay, torque versus armature current, which is also called as electrical characteristics. And the second one is between the speed and the armature current. And the third one is between the speed and the torque. Okay, so this speed and the torque gives the mechanical characteristics. Okay, so here it is called as mechanical because of torque, and here it is called as electrical because of the armature current. Right, from various graph, you can notice that in a DC shunt motor, the speed is fairly constant, but the starting torque is medium. Okay, and then in DC series motor, you can notice that there is a high starting torque, and since it is having a high starting torque, no load condition is dangerous, which may lead to accident. Okay, and it can operate at variable speed. Right, and then when you come to DC cumulative compounded generator, okay, it is having high starting torque, and but the no load condition is allowed because of the controlling nature. And in differentially compound DC motor, the speed increases as the load increases. So these are the inferences from the graphs we have discussed earlier. Okay, and based on the characteristics, there are various applications of these types of DC motor. Thank you.